Welcome, I'm John Terrell, Aviation Maintenance Instructor. In this video, you'll learn how to conduct a magnetic particle inspection. Aviation requires materials that are both strong and light, and parts made from those materials must be engineered to take full advantage of those characteristics. A part can't generally be made twice as strong as necessary because it would then be twice as heavy as required. Stress and strain can create microscopic problems that may grow into cracks and fissures, which can cause the parts to fail in flight. We need to detect these problems while they are still microscopic. This means we must use an inspection procedure that is more powerful and sensitive than simply looking at a part with the unaided eye. This procedure must also be conducted in a manner that both ensures the parts are safe to use and allows them to be put back into service after the testing is completed. This is accomplished through non-destructive testing. The most common method of inspection for highly stressed engine parts is magnetic particle inspection, or MPI. MPI is accomplished on this peculiar-looking machine. The basic premise of MPI is that we magnetize the part by passing high current or strong magnetic field through the part and then cover the part with a ferromagnetic fluid that contains very small iron filings which stick to the part. When a very small crack or fault near the surface is present, the iron filings will gather around the fault. The small iron filings have a coating that makes them glow or fluoresce when subjected to ultraviolet light. So after covering the part in ferromagnetic fluid, the curtains are closed to create a very dark environment, and a UV black light is shined on the part. This makes it easy to see any concentrations of glowing iron filings which might indicate the presence of a fault. We saw several places where iron filings had gathered. We call these indications. An indication may or may not represent a fault that requires the part to be replaced. If an indication is determined to be a cause to discard the part, it is referred to as a defect. While the process of performing a magnetic particle inspection is fairly straightforward, analysis of the results is not. Special training and certification are required to perform MPI analysis on aviation parts. Remember that to get the iron filings to stick to the part we are inspecting, it had to be magnetized. If the part passes inspection, it can be put back into the engine, but not before it's been demagnetized. If the part was placed back in the engine without demagnetizing it first, it would attract all the metal from engine wear that is usually carried by the oil into the oil filter. This would cause very rapid wear and failure in all the parts associated with its operation, including bearings and other wear surfaces. Microscopic cracks and other faults in highly stressed parts can rapidly grow large enough to cause the part to fail. This can and has resulted in the loss of aircraft and the loss of life. Part of the process of maintaining an aircraft is identifying and evaluating these defects before they cause failure. Non-destructive testing, including magnetic particle inspection, are proven methods of finding and correcting these issues before they affect the safety and reliability of the aircraft. Thanks for joining me to learn about conducting a magnetic particle inspection. Look for our other videos on aircraft maintenance.